Hello, geometry students. My name is Emigh, and this video is our discussion on section 3.4, proving theorems about parallel and perpendicular lines. Let's start with the perpendicular transversal theorem. So the theorem says that in a plane, so you have to be able to write it on one piece of paper, draw it on one paper, two-dimensional, okay? Let two parallel lines be cut by a transversal. All right, that's something we're used to. If the transversal is perpendicular to one of those lines, then it is perpendicular to the other line. That makes sense. Let's look at it in symbols and then the figure, if you weren't doing that already. So if the two lines, if we're told they're parallel, okay? So if this geometric code exists, it's there. And we know that the transversal is perpendicular to one of those lines, so that would be this geometric code right here. Then we're allowed to say that the transversal is also perpendicular to the other line. So we're allowed to, given this geometric code, this one, and this one, so those three markings, that allows us to add this fourth marking right there. Justification, perpendicular transversal theorem. All right. Next theorem, two lines parallel to a third line. So the theorem says that if two lines are parallel to the same line, then all three lines are parallel to each other. Okay, this one nice and makes sense, easy to wrap your head around as well. It says that if line A is parallel to line B and line B is parallel to line C, okay, so let me show you that in geometric code. If this single arrow mark is there and the double mark is there, then we can say that line A is parallel to line C. So if we have this set of markings and this set of markings, we're allowed to say that the three lines are all parallel to each other. All right, let's try proving the perpendicular transversal theorem that we just talked about. So what we are given is, in a plane, line L is parallel to line M, and our transversal is perpendicular to line L. So we're given, in code, we're given all of that stuff, and we're being asked to prove the addition of this code right here, okay? That's what we're being asked to prove. Okay, so we start with all the given stuff, and then we know we're finished when we can state that in the statement slide. So the last statement would be T is perpendicular to M. When we can state that, we know we're finished with justification. All right, so let's make our first statement, the given information. Let me erase all my scratch work and redo it. So we just take what's given and we make that our first statement. Justification, given, okay? So we always know how to start without even really strategizing yet. Now it's time to strategize and think our last statement is going to be T is perpendicular to M, justification. So we really just have 5 blanks to fill in. 1, 2, 3, 4, and 5. A lot better than the 8 that it looked like originally. Okay, so now we need to strategize on how we are going to fill in, get from statement 1 to statement 4. So I want you to pause this video right now, take a look at that figure, think about a puzzle, a strategy, any moves that you can make algebraically or using theorems, definitions, postulates, converses of theorems, anything that will get us to our fourth statement. Go ahead and pause the video and try that now. Welcome back. If you are somehow thinking angle 1 and angle 2 are corresponding angles, then you're on the right track. Angle 1 and angle 2 are corresponding angles. And we have a theorem that says that if the two lines are parallel and cut by a transversal, then corresponding angles are congruent. That's the converse of the corresponding angles theorem. So that would allow us to add this marking right here, because 1 and 2 are congruent. Well, if angle 1 and 2 are congruent, then angle 2 also measures 90 degrees. Well, if angle 2 measures 90 degrees, then by definition of perpendicular lines, T would have to be perpendicular to M because they intersect at a 90-degree angle. So that's our strategy. Let's write it out now. Our first statement would be angle 1 is congruent to angle 2. Justification, corresponding angles converse. So statements are all things that have like the congruent markings, the parallel markings, the perpendicular code, an equation. If you had an equation like adding two things together to equal 180, all of those things go in the statements column. All the reasons are like given, definition of vertical angles, corresponding angles theorem, corresponding angles converse, stuff like that, okay? So our next statement that we would want would be stating that angle 2 is a right angle. Justification, definition of right angles. We know that because angle 1 right here is also a right angle. Okay, it was important that we state that angle 2 is a right angle because that is what's necessary for us to now state that T is perpendicular to M. Justification, definition of perpendicular lines. All right, I hope that wasn't too bad. If you need to rewind and watch that a couple times, please do. Proofs are not easy, but with practice and knowing the basics, you can get through them. The basics being start with your given stuff, end with what you're being asked to prove. Make sure your statements over here are your equations or your congruency statements, and your reasons over here are your definitions and theorems. And with practice, strategizing, and then taking that strategy and putting it into these 2-column proofs, you'll be able to get through these. All right, another theorem that we can use for that justification or that reasons column are theorems about perpendicular lines. So this first one is, if two lines are perpendicular, then they intersect to form 4 right angles. So the theorem says that if line L is perpendicular to line M, so if this geometric code exists, then look, you can add all of these, this one here, and this one here. All 4 of those angles would equal 90 degrees. And it makes sense that if this one equals 90, this one is vertical to that, so that would have to equal 90. This one's a linear pair to it, so it'd have to equal 90 because I'd have to add to 180. Same thing with this one here. Vertical angles and linear pairs, supplementary angles, would get us to add all 4 of those 90-degree markings. Here's another theorem. If two lines intersect to form a linear pair of congruent angles, then those lines are perpendicular to each other. All right, so check this out using the formula here. If we have a linear pair, okay, I'm going to draw one arch over top, just showing that those two, angle 1 and angle 2, form a linear pair. And we know that because this appears to be a line, and figure assumption says we're allowed to assume that is a line. So those two angles have to add to 180 degrees. Okay, now focus on this part. If those angles are congruent, then that means they have to have equal measure. So there's only one option for the angles to have equal measure and add to 180. They'd have to be 90 degrees each, because 90 degrees plus 90 degrees is the only way to add 2 equal measures together and to get to 180. So that's why the theorem says, okay, you can say that those are in fact 90-degree angles, or those lines are perpendicular to each other. All right, let's practice finding measures of angles. We're asked to find the value of x. So that would be right here. All right, well, looking at this figure, they've given us a few measurements. Ooh, we have this 190-degree marking. That 190-degree marking right there says that our line N is perpendicular to line L. We have that just from this one marking right here. And if that's the case, remember we can add all the markings like that. So how does that help us with angle X? Well, just try to focus on this part of the figure right here. I'll even redraw it for you to, just so the rest of the stuff doesn't distract you. So this is 63 degrees, and this is our X many degrees we're being asked to find. So write an equation with an X in it, some kind of balance. What equals what? Well, 63 and angle X, those have to be complementary angles. They have to add to 90 degrees. So you can say 63 plus X equals 90. All right, let's see how that looks written out. Measure of angle 1 equals 90. That makes angle or line N perpendicular to line L. And there's our equation that we translated to. Solving for X, we get X equals 27. Just gonna do a quick check of my work. 63 plus 27, that equals 90. Yep, looks good. So this is a acute angle measuring 27 degrees. All right, makes sense. We could find Y too. They didn't ask us to find it, but you could if you want in a similar fashion. All right, thank you for joining me. My name is Emigh, and that will conclude our discussion on section 3.4 and on chapter 3 in its entirety. It also concludes our discussion for your test number 1 material, which is on chapters 1, 2, and 3. That is true at least as of summer of 2020. See you next time.